Hello everyone, welcome to Statics. My name is Paul Marquardt. I'm going to be trying to teach you a full semester of statics by video here, and it'll take small chunks of videos, but we're going to try and get through the entire semester just by video, and then we'll go from there. So hopefully we'll cover everything you need to know for a statics course, wherever that statics course might be. Anytime you have questions, be sure to leave something down in the comment section of the video, and I'll get back to you as soon as I can, and or produce another video to kind of help fill in some blanks. So the foundations of statics starts off with Newton's second law, force equals mass times acceleration, right? Force equals mass times acceleration. And so a couple of different things we want to talk about here. First off, forces and accelerations are what we refer to as vector quantities. And so we're going to really talk about vectors at length here in a little bit. Right, so these are vector quantities. What does that mean? That means that they have a magnitude or a size, and they have a direction. So a direction could be right, could be left, could be up, could be down, north, south, east, and west. Those are, of course, are pretty much in 2 dimensions, but they can also be up and to the right and towards the camera, or up and to the right and away from the camera. So we can be in 3 dimensions as well. We won't go beyond 3 dimensions in this class. So we're going to spend some time talking about vectors. Generally, we have a vector quantity. We say F, we put an arrow over the top. There are other symbols that make a value a vector besides just the arrow over the top. Ask your instructor what he or she prefers before you move on, but I've seen 2 or 3 different symbols in my time, but I'm going to use a little arrow over the top. Acceleration is also a vector. It has a direction. We'll talk about what acceleration is. Really not in this course. We're going to wait for dynamics before we do that. And then mass is a measure of an object's size. You've got to be careful with size. That could be length or it could be mass. But we'll talk about its quantity, how much of the object there is. Okay, we'll get into that in more detail later on. So that's Newton's second law. We're also going to look at Newton's second law as it pertains to rotations. Right? So if I have a ruler here, and I'm holding it up, I'm applying forces, right? So gravity is pulling the ruler down, and if I let go, it falls, right? But if I'm holding it up, I'm applying a force with my left hand. This is actually my right hand, but your left as you're viewing it, and the right hand side as well. But I can also allow it to rotate, right? So there's rotations going on as well, and that is created by what we call moments, or torques. In physics we call them torques, in statics we'll call them moments, right? But that causes a rotation. So there is, Newton's second law also has a rotational format, and that's mass, not mass, my apologies, that's moment, which is a vector quantity, equals rotational inertia, or mass moment of inertia. We'll talk about that much later on. And then alpha is an angular acceleration. So how quickly is the acceleration, or excuse me, how quickly is the rotation changing, right? The rotational speed. So for example, the second hand of a clock rotates nicely, I guess it goes this way, rotates constantly. So there is no angular acceleration because it's continually moving at the same speed. But if you're on a merry-go-round, when the merry-go-round begins, it's not moving at all, and then it gets faster and faster. That's a rotational acceleration. The speed is increasing, or when we turn off the motor or stop pushing it, the speed will decrease. Those are accelerations. Talk about that more in dynamics in another set of videos later on down the line. Okay, so these are some representations of what we're going to be starting with. In fact, in statics, it's even easier because we're going to assume in statics the acceleration is equal to 0. Because it's not going to be moving. It's stationary. Static means stationary. It's not moving. It's not going to move. If I throw an object up in the air at the top of the flight, it stops, but it's going to continue moving, right? So velocity equal to 0 is different than acceleration equal to 0. Acceleration equals 0 means it's not changing velocity. So if it's not moving to begin with, the velocity is 0. And the acceleration is 0, then the object doesn't move, right? So that's static. And if it isn't rotating and it isn't going to rotate, then the moment will also be equal to 0. We're going to talk about moments later on as rotational forces, the rotational counterpart, if you will, the force. We'll get to that in more detail later. Okay, here's a good start, and we'll go from there. Be sure to leave any questions in the comments below. Thank you.